Let's see what happens when we carry out the electrolysis of water. We take this apparatus. These two act as electrodes. They're connected to a switch and to a bulb. So now we have pure water inside this vessel. So let's see what happens. When the switch is switched on, only on connecting the two rods, we see that the bulb lights. So we need a closed circuit for electricity to flow. So pure water does not conduct electricity on its own. But when we add salt, observe that the bulb lights on its own. This shows that when we add salt to pure water, it makes the circuit complete. So it becomes a closed circuit and so electricity flows. This means that pure water is not a conductor of electricity. We add some substance to ionize water into its ions. In laboratory, we add sulfuric acid. So when we add sulfuric acid, water dissociates to form H plus and OH minus. Sulfuric acid dissociates to form H plus and sulfate ions. So now we have 3 ions in the solution. Only one positive ion, that is hydrogen ion, and 2 negative ions, that is hydroxide and sulfate ions. So now let's look at the electrode reactions. That is the reaction taking place at the cathode and at the anode. Let's start with the cathode. So the cations migrate at the cathode. In this solution, we have only one cation, that is H plus. When we have only one cation, this particular cation migrates towards the cathode and is discharged at the cathode. So the reaction taking place at cathode is H plus migrates towards the cathode. To become neutral, it gains one electron and becomes H atom. H atom on its own is not stable. So it combines with another hydrogen atom to form hydrogen gas. So the product formed at the cathode is hydrogen gas. Now let's look at what happens at anode. 2 anions are migrating towards the anode. There is hydroxide anion and sulfate ion. So now out of these two, we know only one anion can be discharged at the anode. So now we have OH minus and we have sulfate. So based on the relative position of these anions in the electrochemical series, we know that OH minus can be discharged at the anode. So let's look at the reaction taking place at anode. OH minus is discharged at the anode. So in order to become neutral, it loses one electron. It becomes OH. This species OH is not stable. It combines with another OH to form a water molecule and oxygen atom. Now again, the oxygen atom is not stable on its own. It combines with another oxygen atom to form oxygen gas. So the product formed at anode is oxygen gas. So let's look at how this process of electrolysis is taking place in the laboratory. These are the 2 electrodes. When we carry out the electrolysis of water, it is observed that bubbles arise from both of the electrodes. This means that 2 gases are released, one at the cathode and one at the anode. Now both the gases are collected in different test tubes in order to test which gas is released at which particular electrode. So the gas at cathode burns with a pop sound. So it proves that it is hydrogen, and oxygen, which is released at anode, it rekindles a glowing splint. So this verifies that the gas released at anode is oxygen. Which gas is released at anode during the electrolysis of water? So at anode, we know that OH minus, the negatively charged anion, it is discharged at the anode. So it gives one electron in order to become neutral. So it forms OH. OH on its own is not stable. It combines with another OH to form water and oxygen atom. Oxygen atom combines with another oxygen atom to form oxygen molecule. That is the oxygen gas. So the gas that is formed at anode is oxygen. Now during the electrolysis of water, observe one thing. These are the volumes of the two gases that are being formed. The volume of gas which is formed at cathode is more than the volume of gas that is formed at the anode. Why is this so? Why is the volume of gas formed at cathode more than the volume of gas formed at anode? We know at cathode, hydrogen gas is being formed. At anode, oxygen gas is being formed. So let's see a few reactions to find out why the volume of hydrogen is more than oxygen. We know that at anode, this is the reaction taking place. OH minus releases one electron to form OH. This reaction can also be written in this form. That is, OH minus gives one electron. So we can write it as a product. Now we take this equation. We can write OH plus OH, the second equation which we were getting when two OH combine with each other to form water and oxygen atom. And now we know that two oxygen atoms combine to form oxygen molecule. That is the oxygen gas. We know from partial equation method that whenever we have two species present on both the sides, so we see oxygen atom on the left hand side and oxygen atom on the right hand side. So we try to cancel the species which are present on both the reactant and the product side. So in this case, we see there are two oxygen atoms, and in that we have only one oxygen atom. So we multiply the entire equation by 2. We get 2OH, 2OH, 2 water molecules and 2 oxygen atoms. So now we can cancel these. So the final equation that we get is 2OH plus 2OH, giving us 2 water molecules plus oxygen gas. Now let's take this equation. And the second equation is the reaction that was actually taking place at anode. We know that OH minus is liberated at the anode. It gets discharged at the anode and it releases one electron. So now we have these two reactions. Again, do we see any species which is present on both the reactant and the product side? Yes, we do. We see that OH is present on the reactant side and on the product side. So now we try to balance it. Here we have 4 OH. So in order to balance this, we multiply this equation by 4. So we get 4 OH minus 4 OH and 4 electrons. So now we can cancel this. The thing to notice here is we'll observe two things. First, when we are not writing any number, this means 1. So now this shows that 1 volume of oxygen is formed in this process. And we see that 4 electrons are released. We know electrolysis is a redox reaction. The number of electrons involved at the cathode and anode is equal. Since this reaction is taking place at anode and it involves 4 electrons, so the reaction taking place at cathode should also involve 4 electrons. Now what was the reaction taking place at cathode? There is only one cation, H+. It migrates towards the cathode. It accepts one electron and it forms one hydrogen atom which combines with another hydrogen atom to form the hydrogen molecule or the hydrogen gas. Since 4 electrons are involved at the anode, so at cathode also we need 4 electrons. Since the electrolytic solution is always electrically neutral, so the number of electrons taking part at the anode is equal to the number of electrons taking part at the cathode. Now we'll try to balance this equation. We have 4 negative charges. So in order to balance it, we need 4 positive charges. Since the electrolytic solution is always electrically neutral, and now we have 4 hydrogen atoms. So to balance this, we get 2H2. So what do you observe? 2 volumes of hydrogen are formed. And this is the reason why during the electrolysis of water, we see that the volume of hydrogen formed at the cathode is double the volume of oxygen formed at anode. As we saw from the reactions, the volume of hydrogen formed at cathode is twice the volume of oxygen which is formed at anode. So the electrolysis of water gives us 2 volumes of hydrogen and 1 volume of oxygen. So these are the products of electrolysis of water.